Hi there! I wanted to make a very short video just to clarify how to use Dalton's law in combination with other gas laws. So what I have open right now is the presentation that was in your week 5-6 agenda. So I'll be starting from slide 29 to show you an example within there. And this corresponds to what you had to do in homework 10-5 with Dalton's law of partial pressures in combination with other gas laws. So in this example, we're given that oxygen is collected over water. So whenever you see the term collected over water, bubbled through water, that's sort of your magical phrase that is going to tell you that you need to do, just a sec. Sorry about that. This is what I get for trying to make a video while my daughter is awake. So when you see that term, collected over water, bubbled through water, there's your magical term that you can have as a clue that you need to adjust for the pressure over water before doing any other calculation. So water itself exerts a pressure, and it depends on the temperature. Will it exert a certain amount of pressure? And so you'll always be provided that. There's a water vapor table in your homework packet. We also uploaded one on your reference periodic table at the beginning of distance learning. So this is a value that you can always use. So we know that we're going to have to adjust for the pressure because it says collected over water. Let's see what else we're given. We're given the temperature, the atmospheric pressure, and we're looking for the volume of the dry oxygen gas measured at STP. So since we're dealing with conditions 1 and 2, we know this is going to need to be combined gas law. But before we can do that, we need to adjust our atmospheric pressure to get the pressure of just a dry gas. Okay, so from the water vapor pressure table, we see that at 24 degrees Celsius, water exerts a vapor pressure of 2.98 kilopascals. So if we use the equation of Dalton's partial pressures, that the vapor pressure plus the gas is going to equal the total pressure, we can simply subtract the vapor pressure of the water, which you get from the table, from the measured atmospheric pressure, which is given in the problem. So that will give you your adjusted pressure. So any calculation that you do after this, you're going to need to use your adjusted pressure. The 102.4 kPa, we don't need anymore. So these are our variables given. Again, the P1 is highlighted. That is your adjusted pressure, your dry gas, using Dalton's law of partial pressures. So here's our combined gas law. So once we plug and chug, notice how our temperature is converted to Kelvin. We cannot do any calculation unless temperature is in Kelvin. And then we simply plug and chug and solve for V2. Keep in mind, STP stands for standard temperature and pressure. And so we know that the pressure, standard pressure is 101.3 kPa. We also know that standard temperature is 273 Kelvin. You looked at standard temperature and pressure at the beginning of this gas law unit. So when you rearrange this equation, this is what you should end up with. You should see kelvins cancel, kPa cancel, and milliliters left in the numerator, which is where we want to be because we were solving for volume, which gives us an answer of 34.1. So I hope this helped clarify using Dalton's law with another gas law. I highly recommend that you go back and look at 10-5. I saw many people forgetting to adjust that pressure before doing the combined gas law. And you may need to use this for the lab that is due at the end of this week. Cough, cough. So this can really help you out. Have a good week, guys. I hope this clarified.